Hello everyone, let's do question number 3 from AP Precalculus 2025 free response questions. Since this is a question number 3, this is again non-calculator question, and this is a really good question on sinusoidal functions. Let's read through the problem. It says, for a guitar to make a sound, the strings need to vibrate or move up and down or back and forth in a motion that can be modeled by a periodic motion. At time t equal to 0 seconds, point X on one vibrating guitar strings starts at its highest position. So it's not starting from rest, but in fact it's starting from its highest position, which is 2 millimeters above the resting position. Then it passes through the resting position, which means it comes back to the rest. Then it goes to the lowest position, which is 2 millimeters below the resting position. Point X then passes through its resting position, which is this, and then again 2 millimeters above the resting position. That's why it's a sinusoidal function, because it's following like a periodic motion, going from its highest point to its resting point. Let's say assume this is the resting, then again its lowest point, again to its resting position, and again to its highest point. The information that we get here, apart from it being a periodic function, is that its resting position and its lowest and the highest positions are both 2 millimeters below the resting position and 2 millimeters above the resting position. This motion occurs 200 times in 1 second. So in 1 second, the string or that point X, which is the on the vibrating guitar string, covers 200 times or makes 200 periods or 200 rotations. The sinusoidal function h models how far point x is from its resting position in millimeters as a function of time. So it indicates a value of how far, which is the distance from as respect to a time. So when I say h of t, ht here stands for the distance at time t. Let's read whatever else the question says. It says a positive value of ht indicates that the position is above the resting position, and negative value we will give when we have the point below the resting position. Now the graph of h and its dashed middle line for 2 full cycles have been shown. Points F, G, J, K, and P are labeled on the graph. No scale is indicated and no axes are represented. However, we have to determine the possible coordinates for the 5 points F, G, J, K, and P. Let's try and understand the problem first. Now, F is a point here on the curve G, J, K, and P, and I want to find out their coordinates. Now, thinking about all the information that has been given to me in the question, I have also been told that this is like the resting position for my curve. And since it's like this is 0 millimeters. If it goes up, this is 2 millimeters. If it goes down, it is again 2 millimeters. But since I have to determine it like coordinates, and the question also says positive for going up and negative for going down, so I will have to assume it like the axis is that this is 2 and this is negative 2 and this is 0. Going on ahead, it also says that at time being 0, the point X starts at its highest position. So this is important that the question does not start, or the point does not start from its resting position. In fact, it starts from its highest positions. Then we go on ahead to understand how will we be finding out the coordinates. So when it says it starts its highest position, it means F is the point that the guitar string should start from. So this is basically our axis is intercepting, because this is the y being 0 and this is the time being 0. So this is when ht is 0, this is when time is being 0. So the red line and the black line indicate nothing but the axis is here. So I can say F would be at a point where time is 0, so 0, and it would be at a point where at a height of 2 millimeters above. So this can be like the point 0, 2. Similarly, P is also very easy to calculate, but now we do not know the time at which P is here. But we know the y coordinate for P will again be 2. For J, the y coordinate will be negative 2. For G, the y coordinate will be 0, because it's on like the x-axis or the t-axis. And again, for K, it will be 0. So I have managed to write down the y coordinates for each of these points, considering that above the resting position is positive 2 and below the resting position is negative 2 and resting position we say is 0. Now going on ahead, I have also written down F's coordinates because a guitar string is supposed to start at when time is 0 at its highest position. So it cannot start from G, K or any point where the graph is shown initially. So that is starting point, right? Now going on ahead, we will try and find out the Y coordinate of all of these points. Let's try and think about that because it has been given to me in the question that the guitar string in 1 second finishes or rings 200 times. So for one period, can we say that it takes 1 over 200 seconds? But because what we are trying to calculate is we have the y coordinates for each of these points, which is the ht coordinates for each of these points. But we do not have the time at which this is string. So we try and calculate because f to p is like one period. So we try to calculate at what time f, g, j, k, and p occur. Now, one period we can say happens in 1 over 200 seconds, which means if I start from f, which is at time 0, p must be the point where t is 1 over 200 because it takes 1 over 200 seconds to complete one cycle from f to p. Remember, f to p is like one cycle. So t equal to 1 over 100 for p. So I can say the coordinates of P then in that case will be 1 over 200 for the T coordinate, and the height we said is a positive 2. So I have also determined my coordinate for P. Now considering that F to P is one cycle, you can see T equal to 0 and T equal to 1 over 200 have been divided into 4 equal parts. 1, 2, so this is 3, and you have 1, 2, 3, 4 equal parts. Now these 4 equal parts would mean 4 equal time intervals as well. So we can say dividing 1 over 200 by 4, which means this will be 1 over 200 times 1 over 4, which is 1 over 800. So this is G, then in that case will be 1 over 800. J will be 2 over 800 and K will be nothing but 3 over 800 with regard to its time. So we knew the y coordinate already, which is the height coordinate based on plus 2 minus 2, but we also determined the t coordinate. So I can say G will be then in that case 1 over 800, 0 because it's at resting position. J will be 2 over 800, which I can simplify as 1 over 400, comma negative 2 because it's below the resting position, and k will have the coordinate 3 over 800, comma 0 because again at the resting position. So these are the 4 coordinates of the point f, g, j, k, and p. Because this is a sinusoidal function, you have to remember to look at the period carefully as well as divide the period into 4 equal parts, because like in a sine function, a period is from 0 to 360, but it has been divided into 4 equal quadrants of 90, 60, 90, 180, 270, and 360. If this is what ideal a sine graph looks like. You have here 0, you have 90, you have 180 here, 360, 270 here, and 360 here. So every sinusoidal function having its period 360 again being divided into 4. So here my cycle had a period of 1 over 200, hence I divided it into 4. Let's read through the B part. Now it says the function can be written in the form of ht, a sine function, where you have a sine bt plus c plus d. We have to find out the values of the constants a, b, c, and d. Now, if you know a sinusoidal function clearly, you would know that A represents its amplitude, B represent its period, C and D are for translations vertically and horizontally. So let's try and understand how would we do vertical and horizontal translations as well as identify the period. We have already calculated the period for the function is a 1 over 200. We also know the formula for calculating a period for a sinusoidal function, remember, is nothing but 2 pi over b. So if I have the period as 1 over 200, 2 pi over b it's equal to calculate the value of b, it's 400 pi. So B is calculated using the period and A is calculated using its amplitude. Since my function is 2 millimeters above and 2 millimeters below, amplitude is nothing but A equal to 2. So then we can say A is 2. Now to think about the horizontal and vertical translations. C indicates any horizontal translations and D indicate any vertical translations. Since the principal axis for the function is at the height 0 itself, we can say vertically the graph is not translated, right? So that means D will also be equal to 0. But if I look at horizontally, ideally a sine function does not start from intersecting the y-axis. An ideal sine function looks something like this as we discussed. It starts from intersecting the x-axis, goes up above, goes down, and then comes up to intersect the x-axis again. So we assume that the starting point of this sine function had it been a cos function, f to p would have fit perfectly. But because it's a sine function, it starts from here. Amplitude and period are not going to change, but this point, let me label it as, let's say, the x point. So x to k would be assumed as 1 period. Now we calculated that this point is 0, 2. This point is 1 over 800, 0. Which means this point ideally again should be 1/4 of the period, which is negative 1 over 800, 0. So which means it's starting from this point and ending at k. I can say that the sine curve has not become a cos function. Don't assume it to be a cos function because it's been given as a sine function. I will have to model it as a sine function. I can assume that the graph has shifted negative 1 over 800 towards the left. And because of that reason, since C indicates horizontal translation, I can say C is nothing but 1 over 800. Why would we make it as positive 1 over 800? Because to shift to the left, you have vertical translation always occurs in the form of x plus a, meaning a units to the left. So since it's shifted 1 over 800 units to the left, we will say c is positive. So our sinusoidal function ht can be written as a, which is 2, sine of b, which is 400 pi, times t plus 1 over 800. And since there's no vertical translation, d is 0. So this is how we have modeled our sinusoidal function for this guitar string. You have to remember the important concepts of your period, amplitude, translations to be able to model a sinusoidal function. So this is a very important question to be done without a calculator so that you can understand modeling of a sinusoidal function very clearly. Let's read to the C part now. It says refer to the graph of H in part A. The t coordinate of G is t1. So they're saying they've not given you that coordinate because that will help you find out obviously the A part. And they've said t coordinate of J is t2. So you know the coordinates, but that's not useful here. They've said on this interval, which means from G to J. On this interval, they have given 4 options about H, the nature of H. It says H is positive and increasing, as H is positive and decreasing, H is negative and increasing, and H is negative and decreasing. Now, if I look at T1 to T2, it is decreasing as a function. However, we also know the middle line is like the x-axis or like the positive axis. Hence, we can say here it's decreasing as well as the values are negative. So in that case, our answer will be negative and decreasing because the values are becoming from 0 to negative 2. So we know it's decreasing in nature. However, it is negative also. Let's understand the second part now. It says on the same interval t1 to t2, describe the concavity of the graph and determine whether the rate of change is increasing or decreasing. Now, if you look at the interval from G to J, you know the curve, the sinusoidal curve, is looking something like this. So can we say from the point G to the point J, the concave graph is concave up? because it looks like concave up here. And if I talk about the rate of change of h, we know for functions which are concave up, the rate of change of the function is increasing. Whenever the rate of change of the function is increasing, it's concave up. If it is decreasing, the function's concave down. That's what we have learned about the concavity of the function. Hence, the second part of the question is quite easy, saying rate of change of h is increasing with concave up function. Hope you have understood this function where you've learned how to model sinusoidal functions for a curve in such difficult problems.